Can you hear me? Hey. Hi, everybody. How you doing? How's build? Good? Right on. Cool. All right, so myself and these fine gentlemen here are going to be giving you a little bit of an overview of how to get started using Unreal Engine 4 for mixed reality development. So yeah, how many people in here have used Unreal Engine 4 before? Anybody? A handful? Okay, great. So some concepts in here that we're going to not go super deep on that are how to use the tool itself. But a lot of that stuff is available in our documentation, and it's some of the most rudimentary things that we've got plenty of tutorials on. We'll be focused more on the API itself and how to leverage it to build your experiences. So, cool. So welcome. First and foremost, who are we? Ryan, who are you?
Hi, I'm Ryan Vance. I'm the XR lead for Epic. So kind of handle the team that deals with MR, AR, VR, all the Rs.
All the Rs.
All the Rs.
Cool. Jackson?
I'm Jackson. I'm a software engineer at Microsoft, and I'm responsible for getting Microsoft bits over into Unreal.
Yeah. And I'm Chance. I work on a number of different things at Epic, including a lot of our demo projects, as well as helping us get support for different new platforms like HoloLens 2 off the ground and moving with content. So a little bit about what we're going to cover today is we're going to talk about what we support for the HoloLens 1 and the HoloLens 2 and kind of what that looks like. Some of the prerequisites you might need to get started today, or actually what we get started with today that you'll need to get started once full support shows up. We're going to cover how to handle touch interactions using the hand tracking system. And we're going to talk a little bit about anchors and pens and how you can create anchors and create content that is pinned to those anchors that stays where it is. And then we're going to cover a little bit about building content that reacts to the user, since we have information about where the user or the viewer that's wearing the headset in the space is. All using a project that we put together over the last few weeks just to kind of demonstrate some of these things. After that, we'll talk a little bit about deploying the device, some of the things you probably already know if you have worked in the UE before, just a slight caveat with streaming. Some of the other features that are currently in progress, and then the schedule in which you might see them. And then the last is a slide for developer resources that you can take a snapshot of today, so you can look ahead at some things if you haven't used Unreal Engine, some places to get started, and some links that will be hosting some of this content whenever it does come online. So let's talk a little bit about what we support right now and what we will support in the future. Ryan, can you give us an overview here?
Yeah, so let's start with streaming support. That actually exists now for HoloLens 1 and will be coming out shortly for HoloLens 2. And when I say streaming support, that's the ability to run on a local desktop and then connect to the device wirelessly. And then you're basically doing all of your rendering and heavy lifting on the desktop PC. All that gets shipped over to the device to be displayed. And then the device sends back telemetry and odometry to the PC, so it knows kind of the state of the user and all the input and everything that's going on that the device is detecting. It's great for taking advantage of a giant machine and pushing really cool visuals and gameplay over the device. It's also great for iteration because it's literally just a button click, it connects to the device, and you're immediately using it. You don't have to go through the whole compile and deploy steps. So as you're kind of bringing your project up, it's a great choice. Next up is our native platform support. So this is new, and this is going to be for HoloLens 2. We're actively working on it now. It says it requires no PC, but you do need a PC to produce the build, and then you ship it over, and it runs natively on the device. And all this is being built on top of our XR framework, so it's the same framework we use for all of our various VR and AR devices. So if you're building content on top of that platform, as long as the device you are targeting supports that capability, your content you build on device A will also deploy on device B and vice versa. And then for each individual device, if they have capabilities that are specific or unique to the device, we'll have a way of getting at those as well, which is also the case with HoloLens 2.
Yeah, what's really cool about that too is you might not be able to get your hands on some of the hardware that's been talked about quite a bit at this show, but that doesn't mean you can't start building content that will work on it by the time you can. So a lot of the concepts we'll be covering today work across other pieces of hardware as well. So if you're used to working in other extended reality hardware platforms, a lot of what you can do there can be directly applied over here, which is really great for not having to build content more than once. Some of the prerequisites, and this is coming from specifically where we are today and a lot of the experience we've gone through over the last few weeks. The project that I built for this talk is all a standalone application on device for the HoloLens 2. And so these are things that I've had to set up here, and they may change. Tyler can maybe speak to a little bit about that once we move forward a little bit, but these are things that we had to do before we could actually get moving. So one, we had to become Windows insiders and get the latest version of Windows 10. Sign up online at insider.windows.com. Pretty straightforward process. Get access to some of the latest and greatest that's there. And then alongside that, we'll need to grab the preview SDK so we can actually compile the code that is required for the devices. And on the Unreal Engine 4 side, we will be releasing later this month the full source for all of this work on our GitHub. And there's a URL here that's a short URL for a reason. One, because it's memorable, and two, because it's not real yet. The actual sources won't be released quite yet, but when it is, you'll be able to get at it here. The reason we went ahead and added this, and same for the project, is so you have a picture of it today as I see it taken, which is great. I won't be able to talk to you in person whenever it does come out, and I want you to have the opportunity to at least know what that is. But we will be hosting those soon.
Yeah, so the current kind of pre-release will be coming out on GitHub at the end of the month, and then we're working towards shipping the full released version in 4.23, which will be later this summer.
Yep. All right, so let's talk a little bit about using hand tracking to do touch interactions. I assume the vast majority of you have worked with the HoloLens 1 or used one, or HoloLens 2 as well, any kind of mixed reality headset. A lot of what you do with your hands is you reach out and you touch things inside your world that don't really exist in the real world. And the way that we've approached that with both the NASA demo and with this project today is using hand tracking and specific key points on hands to actually know that you're overlapping with something virtual in the space. So how many touch points do we track on each hand?
26.
26, which is knuckles and palm and wrist, are all available here. And there's a really just simple a call that we'll show here in a second that you get. It's called get hand tracking, get hand transform for key point. You pass the one you want in. So we care really about the index finger here, and that's what we use. And this little guy right here, does it animate? Yay, my GIFs work. You'll see me reaching, and I'm spawning a new object here. It's a robot. I'm able to spawn him and pin him on the desk there. And this is just using that simple API call. So let's take a look at what that looks like inside the editor. So this is the blueprint graph for my pawn. Now, the pawn is traditionally what you use to represent your viewer, or your player, or your user in the scene. It's a part of the gameplay framework that represents the person that's actually driving the experience. For us to get started with hand tracking, what we need to do first is we spawn a couple of motion controller components. And these are also part of our XR framework. It's the same way we've done other hand tracking or other device tracking logic built on the platform. So we spawn a couple of those and we add them to our pawn. We make them children, you can see here, of the root of the camera component. And once that's done, you set a hand for each of those, and then your hand tracking is ready to go. Now, right now, we're calling get touch or check touch for two different hands. Let me see if we can get the grab back up here. Every frame we're going through really quickly and doing a quick check touch on left hand and on right hand, and we're passing the key point of index tip in. This is an enum that you can kind of see all the other individual points that we track in here. And if you ever wanted to draw a debug and kind of figure out what's going on with your hands, you can actually just draw little dots on all these individual key points, or draw lines between them and actually draw out a physical hand so you can kind of see what's going on inside your application.
Kind of fun to get like little.
Yeah, it's great, right? Little skeleton hands moving around in your space. Super cool. And so really, this is the winner here, the get hand joint transform call. And what this does is it passes the hand and it passes a key point in, and it returns a transform value. Now, transform value is going to give you world space information about where that specific joint is. And what I'm doing here, it might be a little bit inefficient if you're really putting this to an actual production application, but it's just showing how this would work here. I'm doing this in every single frame, and I'm doing a quick sphere overlap for specific actors in the scene with a really small radius, so it's like a little circle that spawns on my hand and checks every frame to see if I'm touching anything in particular. Now, see that I have this actor class filter for interaction object. I don't know that I have that open yet, so I'm going to go ahead and pop it open. And you'll see that this is just, that's the wrong one, there we go. This is just a little object in my scene that represents my little menu buttons. It's got a box collider on it, and that's what receives those. Oh, I've been hit, so I can tell that check touch that, yes, so we did find something. So what I do for this is, for all the actors that come across, I cast them quickly to that interaction object, and then I tell them that it is touch. This is a local member variable there that helps drive some of the touch logic. But because of that, I'm able to do just this right here on each of these buttons here. So that's the logic that's driving that, and that's how I handle it. But so let's talk a little bit about anchors and pins. Anchors are really cool because they represent like a consistent 3D space, or a 3D location in your world space that is kind of the same every time you try to get at it. So you create anchors inside your world, and then you can access them by name later to get information about what they are. So it's really powerful if you want to pin things to your desk or to your wall around you. Say you're wearing your HoloLens at your desk, and you want to have your calendar on one side and your little debug rubber ducky on the desk in front of you. You might build a pin called calendar on the wall and a pin called rubber ducky there. And what's really neat about that is you can just use that information to say, hey, every time I come back here, those things need to be there, and you can write that into your application based on those names. Anything to add on anchors?
Yeah, another cool thing with anchors is because they're a point in world space, any content that you're pinning to it can be in local space. So it can be relative to that anchor rather than relative to some arbitrary world origin.
Yep. Yeah, so let's take a look at what that looks like. It's actually the same animated GIF you saw before. I'm actually spawning these right now, a drone and a robot. You might recognize these assets from our Robo Recall kit. We use them because they looked good in MR. And I'm spawning them in these specific locations, and I'm creating a pin for them, which creates an anchor that lets me associate those two things together. So let's take a look at what that looks like. So in my WMR spawner menu, I'm able to spawn an actor the same way that I normally would in Unreal Engine. I've stored this variable locally here from another class, so I know which one to do. It's part of the bigger logic here. But I spawn it at a location that is specifically where I told it to spawn based on a little preview. And then after the fact, I'm calling this function call called createNamedARPin. Now what this does is it creates an AR pin in the space, and it creates a WMR anchor at the same time based on a name. Since I'm dynamically building these things, I want to give it a special name that I can use later. And so I've got display name, and I'm adding a timestamp to it. I'm saving that down into this AR pin and that AR anchor. And I'm pinning that to the world transform in the same exact spot that I spawned this character. So they're right there on the exact same point. And then I'm pinning the component together. You'll see I'm able to grab the actor that I spawned, grab its root component, and then pin it to that spot. And that's what keeps it in space in that runtime. Now, you see here I'm also adding it to a local array of active pins. And the reason I'm doing that is because, I just looked down at that monitor, I thought it was still up there, sorry. The reason I'm doing that is because you can build anchors and pin things to them inside a specific run of your application. And then if you reset it, you can have them wipe away. You can have them persist only for that session. Or you can save them down, so later when you come back, those things are ready for you to go again. So let's take a look at what that looks like. The most thrilling GIF here, Save Pins button. Magic. All right, let's flip back over and look what that looks like. So my Save Pins button, what that does, it's accessing the active pins array that I have currently stored. And I'm able to call just save AR pin to WMR anchor store. And what this does is it takes the information about that transform that we've created for the anchor and saves it down into the device. And this can be queried later. I can get it whenever the device turns back on or when the application is run again and do something fun with it. So what does that look like? What is something fun to do with that? Did that go over? Let's see. Great. So now I can come back through on a subsequent run through here, and I can reload from pins, and it respawns all the items I had here before. So before I had spawned a drone, and a robot, and placed them in the space here. And I'm able to then now go through load pins and bring those back up.
It's probably worth talking about the kind doing this in the cloud in the future?
Yeah.
Yeah, so we have Azure Spatial Anchors, which post-launch we'll be exploring adding all of the benefits to the mixed reality toolkit into Unreal. And with that, a lot of the Microsoft services that you might know and love from existing AR stuff that you've done. And so spatial anchors in Azure can be uploaded to the cloud and then viewed with a whole bunch of different devices as well.
Cool. All right, so let's take a look at how I'm respawning all the dynamic information based on that pin information. How do I get back to this guy? Great. So back to my spawner menu. Let's see. Oh, no, sorry, load pins. So when my load pins button is selected there, I'm calling this load WMR anchor store pins, and I get a response of WMR AR pin objects. Important to call out here that this isn't always readily available right off the bat. There's a quick call that says WMR anchor store ready. So we can call is WMR anchor store ready. And if this returns true, then it's good to go. Right now, you would set this up on a timer and just check every once in a while to see if it's ready. It usually takes about half a second after the first time the application loads. Eventually, we'll be moving this into an event that you can bind to and just say, hey, once they're ready, then we can go ahead and spawn these things and get them ready. But just wanted to call that out right now. I'm not doing that in this project for right now. So as I get all these back through here, I'm able to take the array element, each pin that comes through, and since I put the name of my class when I spawned it into that anchor ID, I can do some quick checking here to see if they contain specific strings. So since I'm only able to spawn 2 specific classes, a biped and a drone, I just want to make sure that a string contains biped or drone, and then I'll do the appropriate logic after the fact. So you'll see biped path sends me up here, and I will spawn actor biped. And I'm actually spawning it at a transform that is in the middle of my world. Doesn't really matter where it is, and I'll show you why in just a second. So right after that, we still have a pointer to that pin that's coming across from that loop. And just like before, I'm pinning our root component to that pin. Basically what that does is that moves the component from 0 space to where that pin is and rotates it appropriately. And if I get a drone, it would do the same thing here. Now, this is a pretty rudimentary example on how you would build dynamic content that you would save back down, or save down and then reload. What you'd probably do is, in like a real production environment, is have some sort of dictionary that uses a unique name for each individual thing that you would save off into the Unreal Engine save system that you could then pull up specific information based on that key, like what class am I supposed to spawn? Are there other initialization settings that need to happen, or other delegates that need to be fired other places? You could do that. And that's how we get the result you see here, where everybody spawns right back where they should. Yay. All right, so we know a lot about the space. The headset knows a lot about the space you're working in. How do we build content that knows about you as the user? A little bit more information than it currently has. One thing that we found that a lot of people like to do is care about where the user is physically located and where they're kind of looking in the general area. Because if I'm here and you're behind me, there's no real reason for me to interact with your content or even waste cycles on running any procedure that is on you. So one thing that comes up quite a bit in conversation is working with things like track space and world space, and it can be quite tricky to understand the differences there, or you can get caught up in the weeds of where we're actually working. And what we try to do is make sure that we provide a consistent place for you to always get at the user and the content in relation to the user. So the important piece here is that the parent of our camera component is the mapping between world space and track space. And oftentimes that is inside your pawn. In this case, it's MR pawn. And you'll see default root scene. So default root scene is your pawn. It's like the default piece of your pawn that you never want to use. I may have mentioned earlier, but in general, in games, you want to sometimes move your pawn. The controller actually moves the pawn through your space. If you've ever worked in Unreal Engine before for a game, it's always that. You drive your player character forward. It's a pawn that moves in the scene. In this case, we actually leave the pawn alone. Moving the pawn actually changes the relationship between track space and world space. And the camera itself, as a sub-object of that pawn, it kind of moves as the user moves. So you'll see here in a minute, I'll play this in editor and we'll drag the camera around. You can see how the content reacts to it. So you may have seen in the demo that the robot was doing something a little bit special with us. He's able to follow us around, point the gun at us, based on where we're currently standing and looking at him. And you'll see on the one here on the right, once I move behind it, it loses where I am until I come back around. So it's using the location of the camera to know where I am, doing some quick vector math, and then trying to figure out how to rotate its animation to point at or to not point at me. Let's take a look at what that looks like. So inside our biped bot here, we're taking some world locations of two important pieces here. One, we grab our player pawn, which is our default root scene, and then we're getting the camera component from underneath that, and then we're able to get world location of where that is. And that represents me as the user in this case. And we're also taking the revolver that he's holding in his hand, the revolver mesh, and we're getting the world location of that. We're able to do some calculation here to get the actual look at rotation, and then we're going to pass pitch and yaw into a couple of local variables that we'll use to drive an animation blueprint. Now, we're not getting into animation blueprints today, but effectively there are ways that we can use data on a specific class to change things dynamically inside of an animation. In this case, we don't animate the entire robot. We're just telling the robot to blend between spaces based on these two variables. Doing a little bit of fudge math here to make sure that we can get the revolver pointing exactly where it is, because it's going to change just a little bit based on where it is in relation to the mesh. But that's less than important right here. And then in the second image here, you'll see I'm able to take that yaw value that I was storing locally and make sure it's in range between 4 degrees and 180 degrees. I use that as well to set this should fire. This is also driving the animation blueprint to drive him from the versus I'm pointing at you. It's kind of neat. Then let's flip back over here. So again, that's what it looks like. So about where the user is looking itself. The drone does the same follow logic that the robot does, except we're applying it to the entire object as opposed to driving an animation. And you'll see here, right when he enters the very center of the viewport, he does this little aggressive emote, because he knows that I'm looking at him and it doesn't like that. Like dog, you don't look it right in the eyes. So how do we get that information, right? Back over to the project. Instead of looking at the actual drone object, we're going to start from the actual pawn in the camera. I've got a function call in here called check HMD look. This is also called every frame in this. Again, might be a little overkill for an actual production project, but just to prove it out, just wanted to show it here. So this one, we take the camera component, as before. We get the world location, gives us right where the user is. And then we also look at the forward vector, which is specifically right where that camera is pointed. And we do some quick vector math to build a line trace that's 300 units out from the user's face. Line trace in Unreal Engine is basically saying, hey, I'm going to shoot this out, and if I find anything, I'm going to tell you what I found. In this case, we're looking for a specific drone. So, hey, we got a hit. Let's go ahead and see what the actor was in that. And then if we find a drone, let's go ahead and tell the drone that the player is looking so it can do the appropriate thing. So forward vector gives you where the user is looking. Forward vector plus world location gives you the exact location where they're looking from. And we're able to just add units to that forward vector to actually get a link out to actually to that line trace. So let's actually go ahead and see what this looks like all in the editor. Another thing that's kind of cool is if you're working in a lot of this content in Unreal Engine, you might not even have hardware that you can test this separately on. I'd say that probably 70% of the work I did here was not on device, and then throwing it on device to make sure that things reacted the way that I wanted them to. So I can play an editor here, and you'll see my menu pop up like before, and I can go ahead and just throw some debug commands out here. So I'm going to go ahead and spawn up a robot, drop him into space. Then I'm going to eject from my pawn here and just kind of get back just a little bit, like this. And he's currently pointing at, if I look for my pawn over here, grab the camera component. It's pointing right at that camera component transform within a little bit of tolerance, right? My fudge math is just a little off. That's okay. Robots aren't that great a shot anyway. And so you can see as I move this, it follows me, right? And I'm able to make sure that using just those components without a headset, without anything here, I can drive that animation and make sure it's doing exactly what I want. And get behind it, and it loses, come back around, it sees. And so I'm gonna come over here, I'm gonna repossess. Now that I'm next to it, I don't see it anymore. And I'm going to spawn up a drone. So I'll put a little drone robot here too and pop back out. And you saw him do the emote right in front of me. I'm able to, again, come in here and grab the actual camera component, snap that there. It's underneath the pawn. And I can rotate that around, move that around to actually emulate what a user would be doing if they're in here. And you can see every time it points directly at the drone robot, he will do the emote.
If you set up the local remoting like we were talking about before, the next step would just hit play in editor, and it would connect to the device immediately, and then you could test it right there without having to do any deploy step or anything.
This is with the streaming?
Yep.
Yeah. Yeah, super awesome. So you might also see that I've got this menu floating around following me too. And that's using a lot of the same techniques that we use to check if the robot is being looked at, except instead of telling the robot to do something, and the HMD telling the robot to do something, the menu itself is looking for the camera and going to say, hey, I need to follow where that camera's going. So let's take a look at what that looks like. Kill a session. Where are you? Follow player. Great. So just like before, we have our rotation calculation that we've used to drive the robot's rotation, or the robot's animation, and we use that to drive the drone's rotation. And that comes from grabbing the scene component, which is just our menu, getting the world location of that, and then getting the world location here of our camera, and doing a find lookout location, and just driving the yaw. We don't really care about pitch or roll in this situation. And that's going to pipe into the new rotation setting for set world location and rotation of ourself. But what about making it follow the player itself and actual locations as well, not just looking at it? We're able to do the same thing where we can grab the pawn's location and forward vector, and then add or multiply by a desired distance from viewer. I think I have this set to 60. So what that does is it makes a new place. It's right outside the user. I'm adding that back to the location of itself. So that's basically 60 units in front of the user. And then I'm using a vector interpolator to move the actual menu from where it is to that new target location over time. So who's familiar with lerping? Interps? Great. So if you're not, basically what it does is it moves something over time as opposed to immediately from place A to place B, or I guess variables. It doesn't matter if it's moving or whatever, but in this case, it's moving this menu from place A to place B over time more smoothly. That way you don't have any noise or jaggies from the micro differences in vectors over time. If you didn't do this and you're just trying to set it directly, you might see a little bit of movement because as the player moves in very little bit at a time, the menu itself will also move and try to adjust based on that new location. V-interps are not cheap. They're not super expensive, but they're not cheap, so you probably wouldn't want to use it for everything. We don't use it to drive animations or drive the rotation for anything else, mostly because everything's so far away from the player, even if there was some noise in it, you wouldn't notice. But since menus are kind of right in your face, sometimes it's easier to do this. It also has a little bit of a floaty effect too, which is kind of nice.
There's also a feature called stereo layers that we're hooking up now, which allows you to kind of achieve the same thing, but leverage the platform to put a quad in the right space. And so that'd be another way of doing the same.
Right. So yeah, and you'll see right here, here's our menu, right? All the little collider boxes and all the things that you can touch out there. It's pretty neat. Right. Where'd the button go? There we go. Great. All right, so back to deploying to device. Say you've built this project and you want to put some robots on your desk and save them, which sounds like a lot of fun to me. I've been doing it for the last couple weeks. What are the ways that you can test this first and then build a package that you can share with friends, or other ways you can do your iterations or just build a project? As mentioned before, we have streaming, and then we have just the native support. You want to talk us through a little bit what that looks like?
Sure. So you've got your streaming option, like I mentioned before. Just put in the IP of the device and hit go. That's essentially it. Obviously, that sticks to your device and your network connection. So if you actually want to deploy natively on the device, you have a couple different packaging options. There's package for basically sharing or distribution. That's going to basically produce a binary that you can then install on the device through the same tools you would use to install any other package on the device. And then there's also launch on, which is essentially the same kind of idea as the play native streaming, where you just press a button and it goes. But in this case, instead, it'll actually compile everything, install it, and then hook up all the debug channels. So once it launches, Unreal's connected to it, and you can get information and telemetry back from the device as it runs. So I'd say most people would start with streaming just because it's really fast iteration. And then from there, probably move to launch on, so you're actually getting debug information as you work on your project, and then eventually package for distribution.
Yep. Yeah, the streaming is great because you get the quick iterations to say, my logic works, everything I expect to do is doing what it's doing. And then launch on lets you optimize for the actual platform that you're going to be working on. You can look at it in real time right there with all your outputs and everything there too, and then packages for when you're sharing it to other people so they can break it and send you crash dumps. Again, thing I've been doing this week, it's been fun. So let's talk a little bit about other features that are currently in the works that we're cranking on right now, have been for a while, that are on the way, and some of the timelines and those things. And this one's Ryan's.
Essentially, I'll just leave you with the laundry list, because that's essentially what we are going to deliver initially in the preview, which I said earlier, at the end of the month. And then we'll continue to hammer on these and update them up until the release at 4.23. And our general release process is there'll be a bunch of preview releases coming kind of midsummer as we kind of iterate and get everything in the right place, and eventually 4.23 will be the main release that we support going forward, which I think both those dates are on there.
And then as promised, some resources for you to go take a look at. If you're new to UE4, definitely check out our documentation and use some of our getting started resources. Within a day, you should be able to be building some cool things and blueprints based on some of our tutorials. Really powerful tool for designers and gameplay programmers to use. And if you're wondering too, all the blocks we showed today for WMR were blueprint blocks. All of the APIs are also available in C++. We call those blueprint calls in C++ quite a bit. Anyway, so we'll have the source at epic.gm/WMR UE4 source. Whenever it's live, again, that'll be later this month. So if you go there today, you'll be disappointed, and I'll be disappointed too. Same thing with this example project. We'll have a copy of this up there too, so you can kind of take a look at it, anything you missed today, if you want to try it out, and just see what else you can do with hand tracking. And hopefully we can add some more features to it too over time.
Also say that if you want to get started, you could, if you have a device that has similar capabilities, a WMR headset for VR or another AR device, you could start on that now and kind of build out the baseline feature set. And then when this comes online and you get access to actual HoloLens too, you can kind of add that extra layer to connect to the unique features on that device.
Definitely. And of course, you can join the forums, chat with other developers about all kinds of different things. There's a extended reality specific subforum there where there's people that have been doing similar for quite some time. And you can help others and get help over at the Answer Hub. Cool. Are we at time or?
We got a little over 10 minutes if anybody has any questions.
Cool, yeah.